how can we perform the frequency response plot? Okay, now let us take another example, the polar plots. I told you there are several methods we can use, or at least 3 methods. Okay, in the polar plot, what we are doing. So in any signal representation, actually we can also use this way. So A plus JB, this is one signal. So this A is called real part, B is called imaginary part. Okay, so the real part is in x-axis and imaginary part is in y-axis. So here you can see imaginary part is in y-axis and the real part is in x-axis. So how can we write this function? So then we have to write like r of omega plus j x of omega. This function we can represent in the graph like this. So all the real part will be represented in the x-axis, all the imaginary part will be represented in the y-axis. Of course, it's starting in the 0. So here you can see there are 4 parts or 4 sections in this graph. This is part 1, and this is part 2, and this is part 3, and this is part 4. So if you talk about this is 0, right? And this is maybe 1, 2, 3, and so on. Here is 1, 2, 3, and so on. And here, this is starting the negative, -1, -2, -3, and so on. And here the opposite. Similarly, -1, -2, -3, and so on. So you can, when you look at this kind of graph, the 4 sections, you know where is the positive and where is the mixing of positive and negative, and here also mixing of positive and negative, and here is the complete negative, this section 4. So you should know that. So when this is the nature of this kind of plots. So the transfer function can be separated into magnitude and phase angle information. So when once after we find the transfer function of any system, we can separate that into 2 parts. One is representing the magnitude, another one is representing the phase angle. For example, this is the transfer function of one system. H of j omega is equal to magnitude. You can see here, magnitude of H of j omega. If you put this kind of modular, it indicates the magnitude. And then the angle, and if you put this sign, that indicates the angle pi of j omega. So this is representing the complete system response with respect to magnitude and also the phase angle. So H of j omega is equal to Z of j omega. We just simply using this another label. So this is called this frequency response plot. So now we are writing separately. So this one is representing the magnitude and this one is representing the phase angle. So for example, the phase angle is falling down from 0 degree to -90 degree. And here is the frequency in the x-axis. So we will see now, this is the actual, if you really use the graph, the plot will look like this. Of course, in for the study purpose, in the books, they use this kind of way. But actually, when you connect the points like this, if you connect the points, zeros and poles, you will have the graph like this, the graph sheet. This is called polar plot